Hope you can hope can clearly hear me now, I guess. Okay, let me share my screen. Okay, first I'm going to explain about Linux booting process. Okay, hope you're able to see my screen. So basically, there are 6 stages of Linux booting process. Okay, one is BIOS. So BIOS is basic input output system. So what will do? BIOS will execute the MBR. So next is MBR. What is it will do? MBR is a master boot record and executes the grub. Then after that grub is a ground unified bootloader and execute the kernel. Now kernel what will do? Kernel will execute /sb init programs. Init what will do? Init will execute run level programs. Run level programs will what will do? Run level programs are executed from run level directories. So this is the about BIOS what booting process of Linux. Basically, there are 6 stages. So make sure that you need to remember this is a very interview, Linux interview they will ask without these questions. These are the basics in Linux. Okay. Now, what is BIOS? BIOS is a basic input output system. What it will do? It will perform system integrity checks. Then after that, it will search and loads executes bootloader program. Then after that, it took for bootloader as a CD-ROM hard drive, whichever the parameters which is defined in BIOS. So how do you go to BIOS? You can enter either F2 or F12 option based on the based on the VM, the server, or the what you call laptop which you are using. So it depends upon the model, Dell, HP. So you may select either F12 or F2 to go to BIOS. Now what will do? BIOS will load and BIOS is a bootloader program and detect and load into the memory. So after that, BIOS gives to control to on it. So once that is done, it simply BIOS loads and executes master boot loader. Okay, what is MBR? MBR is a master boot record. It's basically it is located in the first sector of the bootable disk. Typically /dev SDA or /dev SDA. So MBR is less than 512 bytes size. What is the size of MBR? 512 bytes. So it has three components. One is primary bootloader. Okay, and that is one is primary bootloader. It has 446 bytes. Second one is partition table information. It has 64 bytes. Third one is MBR validation check. It has 2 bytes. So it contains information about MBR contains information about grub. So in our Lilo we use older operating system like RHL 4, 5 we use Lilo. Now RHL 6, 7, 8 we use grub configuration file. Now after that what we'll do? MBR loads and executes bootloader, grub bootloader. Okay, that is a functionality about MBR. Now let's talk about grub. So what is grub? Grub is a ground unified bootloader. So if you have multiple kernel images, okay, installed on your system, so you choose which one to be executed. So you can define those parameters etc grub.conf file or boot grub.configuration file, those parameters. Okay. So now after that, what you do? Grub displays splash screen, waits for few seconds. So if you don't enter during booting, you will define these parameters. Okay. If you, I mean grub.configuration file, you will mention this timeout. You can see right. This is what is talking about splash image. So 5 seconds is defined, so it will check 5 seconds. Okay. Now grub has knowledge on the file system, so it has knowledge. The latest grub has it has knowledge, but older Lilo it doesn't. Okay. Now grub configuration file I already told you boot grub.conf file RHL6 and etc grub.conf file is linked to this. So the following simple grub.conf file. So default 0, timeout 5, splash image, hidden menu, CentOS, root, kernel, initd. What is default? Default is 0. Means it will look for the first kernel file. Okay. If you want to boot kernel, we have two or three kernels. You can select, okay, if you want to boot first one, you select default 0. Okay, if you want to boot second one, mention default, you change the value to default 0 to 1. That's what you can do. So that is about default, and timeout I already told you. And this root is the local one, the disk root file system. Okay, local disk. I mean root hard drive. It will look root hard drive. Okay. Then after that the kernel image. So boot VM line z file. I told you, right? Boot inside boot. These are the VM line z image. This file will be there, and inside boot init.rd image file also there. So these are important files which it has picked from grub configuration file, and you will define this one kernel image and init.rd image file. So now let's talk about yes, it contains kernel init.rd image, which I already told you here. Okay, now simply grub just loads and execute both these images, kernel and init image. So it will pass here now. Now next functionality is kernel. So what does kernel do? Kernel mount the root file system root etc grub.conf file. Next one is what it will do. Kernel will execute slash has been in program. So once that is done, it will check run init was the program was executed by Linux kernel. It has the process ID. You can check this command. What ps-e pipe and check the PID. Okay, init stands for initial RAM disk. So init.rd used by kernel temporary root file system until kernel is booted. So what will do init.rd? Basically, it will use the kernel to mount the file system, okay, until kernel is booted. That's the functionality of about init.rd. This will do, okay, and it also contains necessary drivers, okay, inside which helps hard drive partitions other hard drives to mount the file system. Now, what is init? Init look like slash ctc init tab file. So this is the configuration file init. What init will do? It look for this configuration file slash etc init tab file, and it has to tell which Linux run level it has to boot. So that is about init. Now in Linux we have 6 run levels in RHEL 6. So what is 0? 0 run level means halt. 0 means halt means shutdown. Now one means single user mode. We do all the troubleshooting, root password recovery in single user mode. Okay, that's what we do. And second is multi-user mode without NFS. So this, if you boot with this one, it is not having NFS services. Now fully multi-user mode is what everybody will use in real-time environment, because it has all the services are running fine. You will be able to access the server without having any issues. It has all the run level services are running on this one, and it has enabled network mode also. Everything will work properly and no GUI. Okay, that is the advantage. So if you don't have GUI, you will work the server, you will access the server very fast, right? So that's the reason we use fully multi-user mode instead of X11. X11 is a graphical. So we use either 3 or 5. So if you want in Oracle in environment or some GUI environment, they want to boot with X11, you change the mode run level 3 to 5. But most of the companies they will use run level 3, because GUI unnecessarily it will take unnecessarily process usage those things. So it impacts the performance of the server. So now 5 means X11 is a graphical mode. 4 we are not using, and 6 is the reboot. Okay, and that's what about reboot. Now init identifies the default init level etc init tab file, and it uses appropriate programs. So init will execute slash etc init tab file. So you open this file, you will have all these modes, whichever you want you can set. But as I told you, we'll have to use only 3 or 5. That's what. If you set module 0, shut down that VM. If you set reboot, it will keep on reboot the server. So we are not supposed to keep. If you want to get in trouble, you can keep as a 6, because server keep on will reboot. So this is about run levels. So RHL 6 we use run levels, but RHL 7 we use targets. Okay, multi-user target, single user target. So there will be graphical target, rescue target. Single user mode means rescue target we call. So that's what. Now run level programs will come picture here. After init RD, then it goes to run level programs. Run level programs are executed from these run level directories: etc run level 0 etc rc.d rc 0.d run level 1 etc rc 1.d Run level 2 etc rc2 dot d, run level 3 etc rc dot d rc3 dot d, okay, etc rc dot d rc4 dot d, run level 5 etc rc dot d rc5 dot d. So this will come. Now you can see, right? Please note that there are symlinks available from these directories. So for this, there will be soft link, symlink will be available. Okay, under etc directory. So etc directory it has symlinks. etc is linked to etc rc0 dot d will link to etc rc dot d rc0 dot d. Same applies for all. Now under etc rc dot d rc star dot d directories, you would see programs like you can see the programs start with s and k. So what is S? Program start with SR during startup. It start the service. Okay. So suppose if you enable send mail, chk config send mail on, so it is automatically it will check this one. It will start the service. Suppose if chk config send mail off, it will stop. It will kill. So that is called K. It will contain K. So program start with K used for kill. So these are the number of S and K, the program names. Those are the sequence numbers which program should be started. For example, syslog-d to start syslog daemon with sequence of 12.8 sendmail to start the sendmail daemon, which uses sequence number 8.0. Programs will be started before sendmail. So you can define those services, okay, in here, in this configuration file, which is mentioned here, right? So you can either start or stop the services during boot itself. Okay, you don't want sendmail, you can stop. So this will check this parameter. I mean, stop means kill. Okay, it will check this one. If you want to enable chk config send mail on. If you want to disable chk config send mail off. So then after that, finally you will be able to see username Linux. So you can see the prompt root, and you'll be entering the password. So that is so this is you'll log into the server. So this is about booting process. So as a Linux admin, you should be knowing this booting process without fail. It's very important. So this is about Linux booting process. Now, let me explain about file system. Let me explain about here. Now second topic, what I can explain. Okay, I'll explain about LVM, right? So let me open the document which I have. LVM. Okay, let me LVM test out. Let me downloads LVM. Okay, LVM. LVM. So LVM, I'll explain. So what is LVM? So basically LVM is a tool, logical volume management tool, which includes allocating the disk, striping the disk, okay, mirroring the disk. So those that is the purpose of LVM which we use. So and LVM has hard drive, set of hard drives allocated one or more physical volumes. LVM physical volumes can be placed on the block devices, which might span two or more disks. The physical volumes are combined of multiple logical volumes. Okay, that's what physical volumes. What is physical volume? Combination of logical values. So now, with exception of slash boot partition, the boot partition cannot be logical value because the bootloader cannot read it. Because Linux system, Linux I told you right, bootloader file, bootloader grub.conf file. So it was not able to read. If it is not able to read, system will not boot, right? So server will not come up. So that's the reason this will not support logical value is will not support. Okay, slash boot file system we cannot make as a LVM because it won't read. It is not able to read. That's the reason we need to exclude slash boot partition. Now, physical volumes can span over multiple drives, span one or more drives. So now let me talk about physical volume. So suppose if you are adding the physical disk, okay, to three servers, 100 GB, 100 GB, 100 GB, and server. Okay, three physical volumes. So this is the structure. Okay. Now boot partition you need to create separately in Linux, right? So this is not supporting, right? Even if suppose also it cannot boot the server. Now logical volume, so it's by where it is picking. It's finally it's coming from physical volume, but In between, there will be volume group. So you will have to create volume group and attach to this physical volume. Then inside volume group, you can create a number of logical volumes. So that's what about the logical volume. So I told you logical volume groups can be divided into multiple logical volumes, which are point to slash home file system slash file system. So we have Linux ext2, ext3 file system. So this is about logical volume. So this is slash home file system you can create. Slash file system also you can create, and 80 GB free space left. Okay, it depends. Okay, logical volume 100 GB. Okay, x3 file. I mean 100 GB it is there. 200 GB, 20 GB, 80 GB. You can create a number of logical volumes. So what is LVM 2? LVM version 2 is the default for Red Hat Enterprise Linux. Now uses kernel 2.6. Kernel LVM can be upgraded from Red Hat Enterprise Linux to about 4 kernel. So this can be upgraded. LVM versions can be upgraded. So this is about LVM. So basically LVM is a simple concept, but you need to get exposure on this. Okay. Now, first what we'll do, first will be their physical disk. That is called physical, okay, value, physical. Okay, first you will have to create physical disk. So what you will do, just pv create whichever the pv is here, slash dev sda. Okay, this is the one as sdc. You created sdc. Now you created physical value. You execute pvs command whether that you have created successfully or not, or pv display command. So you can do like this. Now once you created physical disk, now you will have to create vg volume group name, right? Vg. Okay, now to create volume group, vg create. Okay, vg volume group name whichever you want to mention. Now slash dev sdc I created, right? This is the disk, right? Physical disk. Okay, you created, right? So you'll have to create physical value associate to you need to associate to this physical disk. So once that is done, you can execute vgs or vg display. This is the command which you can execute. So once this is done, now you'll have to create what you called logical volume. LV create LV logical volume LVM. That's what we are talking about, right? LV create hyphen L. Suppose you want to create 50 GB. Okay, you can create capital G slash DV slash DV VG name, whatever you want. You can't use Oracle. Say Oracle volume group name and logical volume ORIFS. ORIFS. Okay, LV create hyphen L, not so. This is some correction. Hyphen L 50G hyphen N. Okay, LV create hyphen L hyphen N. Okay, well, logical volume name. Okay, what you do logical volume name? I'll just make correction. Never mind. LV create hyphen L LV name. LV name. Uh, ORIFS. Okay, VG name you can give. Okay, VG test. Okay, LV create hyphen L 50G hyphen N or IFS. This will create 50 GB of logical value. Now you can type LV display command, LV display command, or LVS command. So this is about LVM. So this is what I covered now. Now I covered. I need to explain about now the file system structure. Okay. So let us do Google file system structure in Linux. File system structure in Linux. So, so in Linux, you should be knowing the file system structure is very important. Okay. So now let me open this one. Okay. So you can see this one, Linux file system, the structure. So I will open some other diagram. It's not proper visible, I believe. Okay. Hope you are able to see this one. So Slash is a very important file system. It's a root file system. So slash is a file system where all this is coming from inside slash. Slash bin also will coming from slash file system. Slash has bin, slash etc, slash dev, slash black, slash proc, slash var, slash tfp, slash usr, slash room. So all is coming from slash. So slash is very important. This is the main root file system directory where all these directories are coming from slash. Now let us learn about now bin. What is bin will do? These are the user binaries will be there. Now what is sbin? All system binaries will be there. What is etc? All the configuration file, etc resolve.conf file. So whichever the configuration files you will have defined, it will be there inside slash etc. Whichever the configuration, mainly resolve.conf file, host file entries in Linux. So inside etc will be there. Now slash dev, device files will be there. Okay. Now track process information will be there. Where variable files will be there. Temporary files to store all the temporary files inside slash tmp. USR. So all user programs will be there. User programs. Home, all user home directories. Suppose you have created two users, user add speed or user test. So those things will be there inside slash home. Now slash boot. So I told you already boot. All the OS configuration file in Linux, everything kernel image, init.rd image, grub configuration file, inside everything is there inside boot. Now library, all the system library files will be there. OPT, arsenal happens. MNT, mount directory, and media. If you want to add the CD-ROM, you can use this mount point media. So now I already told you slash root. Every single file and directory start from slash root directory. Okay, that I already told you. Only root has right privileges. Other users they don't be able to access because they should not, because inside if anything they delete, you cannot boot the server. Server will crash. So root is very important in Linux because all the file system, all these directories, all these important directories are coming from slash, right? So root is very important. So you're not supposed to delete inside slash anything. We even slash file system also inside whichever this file system structure, it should not be full. If it is full, then you will get OS errors. Okay, you cannot even boot the server. So you need to make sure that it slash root file systems, all these directories has enough space. Okay, that's what you'll have to take care when you create a file system structure. Okay, when you create a partitions. Okay, when you create a file systems. Okay, now let us talk about bin. So bin contains binary executable files. All the binary executable files slash bin, it has information. Slash sbin, bin sbin contains binary executable files. Okay, slash sbin reboot, slash sbin IP tables, slash sbin ft's. So all these commands, whatever you execute, it's coming from slash sbin. Same etc configuration file. I told you, right? All the resolve.conf file, log rotated conf file inside etc will be there. Dev files contains device files. So TT1 demo, these files will be there. Proc, process information contains information about process, PS pseudo file, variable files. Var stands for variable files, contain file that expect to go under this one. Var log, this includes var packages. Okay, var log packages, data files, var lib, var mail. So all the system log files. Okay, these are very important inside var. Okay, var log messages will be there. Var log packages, var log inside var mail also will be there. Okay, if mail is not working or if any user mail directory is full, you'll have to check this one. If server is, we are running out of memory and the server, our server is getting crashed, where you will check? You'll have to go to inside varlog. You need to check varlog messages. You want to check any kernel related message, you have to go to inside varlog. You need to check dmessage log. So this is very important in Linux slash var file system also. And temporary, basically temporary basically is to create temporary files or to copy temporary files just for temporary. It's like to reboot the system, all the files will not be present because we only do the activity temp. We, if you want to copy any files, if you want to test it, user home direct users also they can copy that data and they can keep for testing, and after that they can delete also because everybody has access inside temp. It has applied sticky information. Now user contains binary libraries, documentation, source code, those information. So user bin contains binary files, user programs. User has been contains system administrator activities. I already told you. User lib contains user bin, SR has been. Now home, this is also very important home directories. When you create John, Nikita, or whichever user you created, all the user home directory, it is there inside slash home only. Okay, home John, home Nikita. So these also all user home directories. If you do user add John, user add Nikita, so the directly automatically will create inside home until unless you change that parameter. Bootloader configuration file, I already explained you this one. The Kenny.Todd image file, VM linejet file will be there inside boot. Grub configuration file is there. So this is important. Library, all the library file that supports located bin as bin library file is there. OPT optional directories stands for optional. Okay. Add an application should be installed under either OPT. Any application you want to test and install the software, you can use OPT. MNT to temporary mount directory. So you want to mount the DVD drive or you want to mount the DVD drive CD-ROM. You can use either MNT or media. Now let's talk about last pods. SRV stands for service contains server specific services related data. So this is all about Linux file system structure, which you should be knowing. In interview also, they might ask this information. Okay. So make sure that we are not supposed to touch slash file system. Inside slash also you are not supposed to touch because these are associated. All this one slash bin, spin, etc, dev, proc, var, temp user, home, boot, lib, opt, media, srv. So this is about that one. So yeah, hope you are now clear on this. Okay, let me stop sharing my screen. So let me stop the record.